Um, so this is the properties of equality. The first thing I want you to do is to write this down. Given, given A, comma, B, and C. They're all numbers, all right? So for addition, you're adding something to both sides of the equation. So let's say if A equals B. What I can know then is that A plus C equals B plus C. And why? Because A and B are equal. Similarly, if A equals B, once again, for the subtraction property, then I know that A, oh, not plus, plus. Then I know that A minus C equals B minus C. B minus C equals B minus C. Because A and B are the same. So, we'll go over some examples in a minute. Multiplication property of equality. Same thing, same kind of thing. If A equals B, I'm not going to use color anymore. Then I know that AC equals BC, right? Division. If A equals B, then I know that A divided by B equals B. Sorry, not A divided by B, but A divided by C equals B divided by C. Okay? For your distributive property, that's where you're just multiplying twice. So AB, A times B equals A times the quantity of B plus C equals AB plus AC. For substitution, a little bit different. Okay? So here, if A equals B, then A may be substituted or replaced or substituted by any B in the expression or equation. Now for any real number A, A always equals itself. 2 always equals 2. It doesn't equal anything else. It always equals itself. We'll see this reflexive property throughout geometry. The symmetric property says if A equals B, then B equals A. The transitive property says if A equals B and B equals C, this is where we cut out the middleman again, then A equals C. Very much like the law of syllogism. The next part, we're going to go through some 2-column proofs. We're going to start some 2-column proofs. And basically, what you want to know is what do I need to do to get from one step to the next step. So I'm going to use highlighters on this next part. Let me go back a page. I'm going to use highlighters. And I want to tell you I will be doing number 1, number 2, and number 3 with you. You have to do 4 and 5. Okay, so let me go back. Okay? So take a minute, get ready. Alright guys, I'm going to put the full screen on for this. It's pretty important. Okay? So, when we're doing the 2-column proofs, things you want to be able to do. Alright? On the left side, these are all the things, these are all like the steps to the problem. On the right hand side, so these are my steps. And not everything is shown. Not everything is shown like you want it to be. And on the right-hand side, these are the properties. These are the properties. Things we didn't go over. We didn't go over things like given. Given. Okay? So that word is very important. It's going to be very important. And the last part we didn't go over is you can write prove, proven, you can write result, proof. This is the end, the product of the two-column proof. Okay? Anyways, so the left-hand side is the steps, right-hand side are the properties. What can be used as reason? Any of the properties above. You can use addition, you're adding something, You're going to say addition, you're subtracting. You don't even have to write all the way. You're multiplying or you're dividing. We'll get to those reflective and symmetric properties and so on and so forth. But for right now, let's keep it simple. Alright? So, first of all, if you're struggling with proofs, you need to look at what changes, or in fact, what stays the same. If you notice, the only thing that stays the same is 4x. This stays the same from step 1 to step 2. What do they do to change, to get rid of -1 and 27 and end up with 28? Did they add, subtract, multiply, or divide something? That's how you ask yourself what the property is. Here, they added 1 to both sides. They added 1 to both sides of that equal sign. They ended up with 4x equals 28. So this is the addition property of equality. This is the addition property of equality. Easy stuff. And if you know algebra really well, you'll have an idea of what comes next, what follows. So if you look at from step 2 to step 3, both sides changed. What did they do to make these steps change? They add, subtract, multiply, or divide. If you look, they they divided 4 on both sides and ended up with this canceling, x equals 7. This is the division property. Division property of equality. Division property of equality. This is not hard stuff. This is stuff from algebra. So if you know that they're adding on both sides, subtracting on both sides, multiplying on both sides, or dividing on both sides, you're good to go. So like I said, I'm going to do number 2 and number 3 with you. You're going to have to do numbers 4 and 5. Then you have a practice worksheet to do, complete, and turn in. So let's look at number 2. I have a divided by -6 plus 2 equals 5. That's what's given. They give me that. They want me to prove that a equals -18. So, like I said before, if you can't highlight, circle what stays the same. Highlight what stays the same. And look at what changed. So I went from +2 on the left-hand side equals 5 to equals 3. So obviously, they subtracted 2 on both sides. You can be specific and explicit and write subtract 2 on both sides. Subtract 2. I like that. Or you could just write the subtraction property of equality. Now, step 3 says a equals -18. How did they get rid of that -6? How did they get rid of that 3? Obviously, they multiplied -6 on both sides. They multiplied. And this goes away. And 3 times -6 is 18. Multiplication property of equality. And if you need to, you can put times -6. You know, BS doesn't mean the bad words, it means both sides. Negative multiply, -6, BS. Last one, guys, and then you have to do number 4 and number 5. Okay? So, look at what changes. If you look, I'm going to highlight what doesn't change. If you can't remember what property is being used, so here, or I've highlighted in blue, what property is being used here, go back and look. If you look, they're distributing that -9 twice. Distributing the -9, they're getting 18x, -18x plus 27. So don't forget the first thing that was given, they already wrote it for us. But the second step, to get to the second step, they distributed. We use the distributive property of equality. So from now on, for equality, I'm just going to write this equal sign. Distributive property of equality. Okay? Look at step 3. What changes from step 3 to, step 2 to step 3? What changes from step 2 to step 3? And what doesn't change? Well, I can tell you what doesn't change. Step 2 to step 3, -18x, still there. So obviously, they did something with that 27. It's positive. And there's a like term on the other side. So they had to subtract 27 on both sides to get 36. So that means they used the subtraction property. The subtraction property of, don't forget the symbol, of equality. For step 4, going from step 3 to step 4, you are dividing -18 on both sides. That means your property is the division property of equality. So the next two problems, 4, 5, I'm actually going to do those with you just because they might have done some extra problems. So number 4, I'm going to highlight what stays the same. So -17, that's the same. 7 plus 7, positive 7, that's the same. The only thing that's different is 2x. So how did I get 2x? Did I subtract 6x on both sides? Did I subtract 8x? I subtracted 6x. But regardless, it's the subtraction property. The subtraction property of, don't forget your equal sign, property of equality. I can prove it. -6x, this goes away. And 8 minus 8x's minus 6x's is 2x's. Now, let's look at what they did next, from step 2 to step 3. So, let me erase this highlighted part. Step 2 to step 3, right? If you think about what did they change? Well, if I look, 2x is still the same. The x term didn't change. The numbers did. So obviously, they did something different. 17 is no longer there, so they must have added it. They did the opposite. They added it to both sides. 17 plus 7, it does equal 24. So this property is the addition property. of equality. So all you need to do is ask yourself, what are they doing to get to the next step? What are they doing to get to the end result? What are they doing to get from step 3 to step 4? What do they do to get from saying 24 equals 2x to 12 equals x? What do they do? If you think about it, they divided 2 on both sides. They divided 2. They want to simplify this, and they divided 2 on both sides. And you're left with 12 equals x. This is the division property of equality. Now, something we haven't done before today in this class is looked at those reflexive, symmetric, and transitive properties. So here, when you flip something over, it flips, or they flip, whatever you want to write. When you see two terms flip, this is the symmetric property. Symmetric property of equality. Or, I'm actually going to let you do this one. You do. Alright? And then you're going to go on to do this page. It's for a grade. Have a blast. Have a good time. Let me see it when you're done.